Good day, wonderful students of Sleek Angels International School. Once again, my name is Aneke Victor, your maths teacher. We had previously discussed extensively on the topic geometry. You can check that out on our YouTube channel, Sleek Angels International School. For today's class, we will be discussing on the topic trigonometry. This topic is mainly for SS1 students and all those having challenges on the topic trigonometry. Before we go into trigonometry, I'd like to tell you what my aim is. My aim is to make us to be able to use trigonometric functions to solve questions. And secondly, use trigonometric tables to determine sine, cosine, and tangent of any angle theta, where theta is between 0 and 360. Before we do this, we have to first of all understand the meaning of trigonometry. Trigonometry is a branch of mathematics that studies the relationship between side lengths and angles of triangles. I take that again. It is a branch of mathematics that studies the relationship between side lengths and angles of triangles. You can agree with me that there are many triangles in this topic. You can agree with me that we have more than one kind of triangle. We have a right-angled triangle and non-right-angled triangles like a scaling triangle, an isosceles triangle, and an equilateral triangle. And I know that if we consider all these triangles, that the topic trigonometry becomes very, very broad. So I decided to concentrate today firstly on right-angled triangles. We know that a right-angled triangle is a kind of triangle that has one of its angles to be 90 degrees. I have here on the board a kind of a right-angled triangle. This shape here represents a right-angled triangle, and this angle here is the 90-degree part of the triangle. For any right-angled triangle, we have the hypotenuse, which is the side facing the 90-degree angle. And the opposite is dependent on where the angle is. The opposite side of this triangle is dependent on where this angle is formed. Because this angle theta is formed here, this is the opposite to theta. And the other side is the adjacent. For any right-angled triangle, the opposite is dependent on where the angle is formed. If this angle was formed here, this would have been my opposite. But because this theta is considered here, this side of this triangle becomes the opposite. This side becomes the adjacent. And the hypotenuse is always constant. It is usually the longest side of the triangle. For this figure, this is the hypotenuse. Now, for trigonometry, the acronym SOHCAHTOA is mostly used to remember or recall the relationship between the sides and angles of a right-angled triangle. The acronym SOHCAHTOA is used to recall the relationship between the sides and the angle of a right-angled triangle. It is written here as SOHCAHTOA. Some lecturers will say, stupid old Harry couldn't advance his troops over Africa. Stupid old Harry couldn't advance his troops over Africa. But mostly it is pronounced as SOHCAHTOA. The SOH means that the sine of the angle is equal to the ratio of the opposite and the hypotenuse. The CAH means that the cosine of the angle is equal to the ratio of the adjacent to the hypotenuse. And the TOA means that the tangent of the angle is equal to the ratio of the opposite to the adjacent. That's the SOHCAHTOA. That sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, and the tangent is equal to opposite over adjacent. I have a few questions that I'm going to use to help us understand how this SOHCAHTOA is used. We have an example here to help us understand how trigonometric SOHCAHTOA is used. The example here says that the angle of depression of a point P on the ground from the top T of a building is 23.6 degrees. Calculate, correct to the nearest meter, the height of the building if the distance of P to the foot of the building is 50 meters. In our previous classes, we had learned angle of depression and angle of elevation. So to depress means to stay from a point and look down below the eye level. So this diagram here represents the question that was given to us. This is the building and this is where the observation was made. This is the point P, and this is the angle from the observer's eye level to the point P. This is the angle formed from the observer's eye level to this point P, and it was given to us as 23.6 degrees. We also know that by the alternate angle rule, this angle formed here is equal to the angle formed here. So this angle 23.6 that was given to us as the angle of depression was equal to this angle. So we can see that we've taken the information here to this point. And we were also told that the distance of the foot of the building to what was observed was 50 meters. What we were asked to find was the height of the building, and H here represents the height of the building. We don't know anything about the hypotenuse because this diagram is that of a right-angled triangle. So from the information we were given, we have the angle, we have this part as H, which is what we're looking for, and that is the opposite to the angle. And we had the adjacent. So from SOHCAHTOA, it is obvious that we were given the adjacent, the angle, and we were told to find the opposite. So we used the trigonometric function that connected tangents, opposites, and adjacent. The tangent of an angle is said to be the ratio of the opposite to the hypotenuse. The tangent of 23.6 is equal to the opposite H and the hypotenuse, which is what? 50. So if I have something like this, I'm going to cross multiply to be able to get the height. So I'll multiply 1 and H, and then multiply 50 and tan 23.6. So I have it on the side as H being equal to 50 times tangent 23.6. I will have to find the value of 23.6 using my calculator or a 4-figure table. You can use a calculator to punch that out. 50 times tan 23.6, and you get your answer straight. Or you check out the value of tan 23.6 first from a 4-figure table, and that is 0.4368. 0.4368. And by the time you also use a calculator to multiply 0.4368 by 50, you get a 21.84. It means that the height of this building is approximately 22 meters, because we were told to find, correct to the nearest meters, the height of the building. You can see the importance of the trigonometric SOHCAHTOA. It has helped us to find the height of this building. This solution, or this process, can as well be used to find the height of our masts, our MTM masts that are close to us. We don't necessarily need to use a tape to look for the height of the mast. If you can use a clinometer to know the angle of elevation of the heights of the top of the mast, and know the distance from you to the foot of the mast, you can as well use the trigonometric function to find the height of the mast. This question I just solved was number 3 question of 2017 WAEC. We have another example here to make us understand the trigonometric SOHCAHTOA usage. And the example says that from a place 400 meters north of X, a student walks eastward to a point Y, which is 800 meters from X. What is the bearing of X from Y? From a place 400 meters north of X, a student walks eastwards to a point Y, which is 800 meters from X. The question says, what is the bearing of X from Y? So this is the place where the student is walking from, and this place is 400 meters from X. So we label this part to be 400 meters. And the question also says that this student walked to a point Y, which is eastward of this place. So the student walked eastward to a point Y, which is 800 meters from this point, that is X. So the distance from the place where he has walked to this point X is set to be 800 meters. The question now is, what is the bearing of X from Y? What is the bearing of this point measuring from this point? So our interest is to know the angle from this direction round to this point. We are sure that this part is 90 degrees. This other part is another 90 degrees. Our interest is to get this point. And this point dotted here is related to this point from the alternate angle theorem. And this is the Z angle. So this part is equal to this part. So if I can get this part, I'll relate it to this part and then add 180, because 90 plus 90 is 180. Now, how do I get this part? I have to know that the places that were given to us in this question were the adjacent and the hypotenuse, because this figure here is a right angled triangle. Now from this, I can know that the trigonometric function that connects the adjacent and the hypotenuse is the C, A, and H. And the CAH says that the cosine of an angle is equal to the adjacent over the hypotenuse. The cosine of an angle is equal to the adjacent over the hypotenuse. The adjacent here is given to us as 400, and the hypotenuse is given to us here as 800. What we were not told in this question is this angle, and we had said that if we can get this angle, we relate it to this point, and then we get the required bearing of x from y. Now, how do I get that angle? We've related it to cosine being equal to adjacent and hypotenuse. So I write that cos theta is equal to 400 over 800, knowing that the adjacent is 400 and the hypotenuse is 800. So I can use a calculator to break this down. 0 cancels 0, 0 cancels 0, 4 cancels 8, and I'll have a half. Theta becomes equal to the cos inverse of 1 over 2. You can agree with me that 1 over 2 is the same thing as 0.5, but put as 0.500 for those that would want to use a 4-figure table to check the cos inverse of 0.5. But if you have a calculator, you can as well use the calculator to punch the shift function of cosine and impute your 0.5. If you do that, you're going to get a 60. So the angle in question is 60 degrees. The angle here has been found to be 60 degrees. And we had said that this angle is related to this angle according to the alternate angle theorem. So it means that this angle here is 60 degrees. Now that we have found this angle, it becomes easy to find the bearing of x from y. The bearing of x measuring from this point. So the angle from the north pole of y round till I get to this line is 90, 90, and a 60. Therefore, the bearing of x from y is 90 plus 90 plus 60. And if you do this, you're going to get a 240 degrees. My first objective today was to teach you how to use trigonometry as it concerns right-angled triangle. The second objective is to teach you trigonometric values that are between 0 and 360 degrees. So we're going to be looking at trigonometric functions of angles between 0 and 360 degrees. This abbreviation CAST, as it is written here, CAST, is used to know the sign convention of trigonometric identities. Most lecturers avoid this section of trigonometry because they understand or they feel that students can as well go to a calculator and get these answers. But on a professional level, we teach this section because we are aware that students go in for JAM exams and maths competitions where they are not allowed to use sophisticated calculator. So it is important for them to learn this aspect of trigonometry. This is a Cartesian plane which divides a circle into 4 quadrants. In this section, A here represents that all trig identities are positive. S here represents sine, and it means that only sine is positive in this quadrant. So this is my first quadrant, and this is my second quadrant. Now in this second quadrant, sine is the only positive trigonometric identity. This is the third quadrant, and in this quadrant, only tangent is positive. All other trig identities are negative. And finally, C here represents cosine. It shows that only cosine is positive and all other trigonometric identities are negative. So I put the fourth quadrant. So in this section of the board, we have our first quadrant written, and in the first quadrant, all angles are positive. And the angles we are considering in the first quadrant are angles between 0 and 90 degrees. In this first quadrant, all trigonometric functions and identities are positive, and the angles there are angles between 0 and 90 degrees. In the second quadrant, we're looking at angles between 90 and 180 degrees. And in this second quadrant, only sine is positive, cosine and tangents are negative, and the acute equivalence, short formed as AE, is giving us phi being equal to 180 minus theta. This is a measure that takes the given angle in the second quadrant to a value between 0 and 90, so it can be checked up from a 4-figure table. In the third quadrant, we're looking at angles between 180 degrees and 270 degrees. In this quadrant, only tangents is positive. Cosine and sine are negative. And the acute equivalence is giving us phi being equal to theta minus 180 degrees. And the fourth quadrant, we're looking at angles between 270 degrees and 360 degrees. In this quadrant, only cosine is positive, sine and tangents are negative, and the acute equivalence phi is given as 360 minus theta. So with these little notes, I can be asked to check up values that are beyond 90 degrees, values that are above a 4-figure table, and I can still get the answer even without the use of a calculator. We have examples here to make us understand the trigonometric functions of angles between 0 and 360 degrees. Like I said earlier, it is possible to use a calculator and get these answers. But in the absence of a calculator, how do I find the value of sine 160 degrees, knowing that 160 degrees is way higher than the values that are given in a four-figure table. So two things I have to always look out for is the trigonometric identity and the angle in question. The trigonometric identity here is sine, and the value here is 160. 160 is in the second quadrant. And in the second quadrant, sine is positive. The next thing I always have to get is the acute equivalence. We had given the acute equivalence in the second quadrant as phi being equal to 180 minus theta. Theta here is the 160 degrees. Phi becomes equal to 180 minus 160, and that is what? 20. We have used these acute equivalents to bring 160 to a value that we can check up from our four-figure table. So we can write that sine 160 is equal to positive sine 20 degrees. Sine 160 is equal to sine 20 degrees, positive sine 20 degrees. And if you use a four-figure table to find the value of sine 20, you will get a 0.3420. Therefore, sine 160 is the same thing as positive 0.3420. You can see that I did not use a calculator, but with a four-figure table, I was able to get the value of sine 160 degrees. The second example I have here is cosine 230. We're being asked to find the value of cos 230 without the use of a calculator. Once I get a question like this, I should look out for the angle in question and the trigonometric identity. In this case, our angle is 230 and our trig identity is cosine. So we say 230 falls in the third quadrant. 230 falls in the third quadrant. And in the third quadrant, cosine is negative. We had said that only tangent in that quadrant is positive. In our CAST abbreviation, only t was positive in the third quadrant. Therefore, cosine is negative in that quadrant. And the acute equivalence, AE, was giving us phi to be equal to theta minus the 180. We had said that in that explanation. Phi, in this case, becomes 230, which is the angle given, minus 180. If you subtract 180 from 230, you're going to get a 50. So we can write that cos 230 is the same thing as negative cos 50. Negative in the sense that 230 is in the third quadrant, and in that quadrant, cosine is negative. So we have our final answer to be minus 0.6428 minus 0.6428. That is if you check cosine 50 from a four-figure table. I also want you to use your calculator to do this check. You can easily use your calculator to press cos 230 and see if it gives you minus 0.6428. That you can do for confirmation purposes. But the aim is getting this answer without the use of a calculator. Now, I know some people might be asking, what if the angle is greater than 360? What if I have a value as large as 910, like I have in my third example? I want you to know that adding or subtracting 360 from a value does not change the magnitude of the trigonometric identity. Adding or subtracting 360 from a value does not change the value of the trig identity. So my aim here will be to bring 910 to a value between 0 and 360. The value I was giving was higher than what we are teaching. We are learning angles between 0 and 360. But the value I have here is 910. What do? I subtract 360 from 910. If I do that, I'm going to get a 550. If I subtract 360 from 910, I'm going to get a 550. And if you notice, 550 is still higher than the 360 in question. 550 is still higher than the value we have been learning. So I subtract another 360 from 550. When 360 is subtracted from 550, we'll get 190. Having gotten 190, we have brought 910 to a value between 0 and 360. Now we are going to be dealing with tan 190. So tan 910 is the same as tan 190. Now, we have brought 910 to 190. Our aim is to follow the same process that we have followed to find the value of 110. So the big question is, where does 190 fall? You can agree with me that 190 falls in the third quadrant. 190 falls in the third quadrant. And 190 is between 180 and 270. So we say 190 is in the third quadrant. And in the third quadrant, tangent is positive. Tangent is positive. The T in the third quadrant indicates that tangent is positive. And the acute equivalence is given as phi to be equal to theta minus 180. Phi becomes equal to 190 minus 180, and phi is equal to 10. Now that we have narrowed it to a value that we can look up from the 4-figure table, we write that tan 910 is equal to positive tan 10. We write that tan 910 to be equal to positive tan 10. So tan 910 becomes plus. Please check up the value of tan 10 from a 4-figure table. You are going to get a 0.1763. 1763. So we can say that tan 910 is equal to 0.1763. You can check this up using your calculator. you're going to get tan 910 to be equal to 0.1763. I have a fourth and final example here for you, and the example says, find two possible values of theta for which 5 cos theta minus 3 is equal to 0. 5 cos theta minus 3 is equal to 0. So how do I solve this? First of all, I'll take 3 to the right hand side of that equation. So it becomes 5 cos theta is equal to 0 plus 3. And I know that 0 plus 3 is equal to 3. The next thing to do is to divide both sides by 5. So cos theta becomes equal to 3 over 5. And in order to get theta, I have to find the cos inverse of 3 over 5. And if you check the cos inverse from a 4-figure table, having converted it to 0.6000 to conform to the 4-figure table format, you will get theta as 53.13. So the first value of theta has been gotten to be 53.13. But the question says we should find two possible values of theta, meaning that there is another value of theta that is lying between 0 and 360 that make this expression true. But the question I will ask myself is, in what other quadrant is cosine positive? In what other quadrant is cosine positive? And I can remember my CAST abbreviation. Cosine is positive in the 4th quadrant. Cosine is positive in the 4th quadrant. So to get another value of theta, I will say cosine is positive in the 4th quadrant. And the acute equivalence given in the 4th quadrant, AE, was phi to be equal to 360 minus theta. If you notice, theta has been found here as 53.13. Therefore, phi becomes 360 minus 53.13. And my final answer as phi is 306.87 degrees. So the two possible values of theta for which 5 cos theta minus 3 is equal to 0 are 53.13 degrees and 306.87 degrees. So we have used the knowledge of trigonometry to find the values of theta in that situation. I hope you've learned something today, and I believe that when giving questions which are very similar to the ones that we've done today, you will be able to solve them. The assignments I've written here on the board are: 1, we should find the values of sine 225. Use the method I used in my example, you'll be able to get that. 2 is cos 318. The third one is tan 217 degrees. The fourth one here is, what is the angle of elevation of the top of a tree 8 meters high from a point on the ground 9.2 meters away from the foot of the tree? What is the angle of elevation of the top of a tree 8 meters high from a point on the ground 9.2 meters away from the foot of the tree? The fifth one, which is the final one, says find two possible values of theta for which 2 tan theta minus 4 is equal to 0. Find two possible values of theta for which 2 tan theta minus 4 is equal to 0. Like you've always done, solve this in your notes, screenshot and send to my email address, which is anekevictor16@yahoo.com, or you can send to my WhatsApp number, which is 070-3937-1313. Thank you very much.